Good morning, everyone. My name is Rob van der Goot, and today I will be presenting our paper on increasing robustness for cross-domain dialogue classification on social media data. This work was mainly done by Marcus and Nicolai, and I was their supervisor. On this slide, you can see two example utterances from social media that are annotated for dialogue classification. The second utterance is a reply to the first utterance, and both utterances are assigned a single label. For this task, most previous work was on phone speech conversations. There's not much publicly available annotated data for web data. One notable exception is the NPS chat corpus from 2006, which is publicly available, and there has been quite some research on it. Now, for our annotation, we use the following label set. This is an adaptation of an ISO standard, but we had to adapt it a bit to be a good fit for our social media data. In this work, we are mainly interested in a cross-domain setup, as we can never annotate all different subdomains that we can find on the web. And on top of that, language is changing constantly. So perhaps the data from 2006 has much lower performance on data from current day social media. More specifically, we are going to transfer from the NPS chat corpus to a more recently scraped Reddit dataset. So we took a subsample of Reddit and we annotated it as well. And we annotated Marcus and Nicolai annotated a part of the NPS chat corpus. On this slide you can see the data sizes. Now note that we don't have an out-of-domain training set, of course, because we're interested in evaluating a cross-domain setup. But we also have a definite test set in domain, so that we can also see if the performance in domain remains high. So we had two annotators. They first annotated for 10 rounds in the previous project until they reached a good kappa score. Here in this graph you can see that the kappa score has converged after the 10 rounds, and then they went on to annotate with the single annotator per utterance. Throughout this work we used the Berta version 3 base language model. This language model was just empirically shown to give good performance, while also not being too large or not too computationally expensive. This model scored 77.11 macro-F1 in domain and 53.92 out of domain. So there is quite a substantial drop if you transfer to an out-of-domain dataset. Then we evaluated three approaches to increase the robustness. The first one is lexical normalization. Lexical normalization is the task of transforming a non-standard language variety to its standard form. More specifically, we use lexical normalization, which is normalization on the word level, and we used MoNoise, a model that was state-of-the-art in the beginning of this project for English. We normalize the input sentences before we do the dialogue classification, and unfortunately we noticed that performance went down a little bit. So they're still within one standard deviation, so we cannot say it became significantly worse, but it definitely did not improve. The second approach we evaluated was label resampling. With label resampling, we tried to make the distribution of the labels more uniform, and thereby hopefully more robust against the shift in distribution across domains. With the label resampling, we used multinomial resampling, and we tested different alpha values to see how aggressive we should smooth. And we found the values that you can see on the slide to be optimal for in-domain and out-of-domain evaluations. We gained 1.5% in macro-F1, both in-domain and out-of-domain, when using label resampling. Then the third and last method we evaluated for increasing robustness was to incorporate the context. We evaluated three different types of context, namely the label of the previous utterance, a binary value indicating whether the previous utterance was sent by the same sender as the current utterance, and lastly the text of the previous utterance. Now, if you try to use different amounts of these pieces of information from the context, you can see different gains in performance, and we obtained optimal performance by using all of them. And then we can gain 7 points for in-domain evaluation and 20 points on the out-of-domain dataset. So this is a very substantial gain. The text turned out to be the most important piece of information. You can see more details in the paper. So to conclude, if we do cross-domain dialog tag classification, the lexical normalization did not help, label resampling helped a little bit, and context is really crucial to obtain optimal performance. On top of that, when we tried to combine these approaches, we saw that using label resampling still helps a little bit on the out-of-domain dataset if we add it on top of incorporating the context. On the in-domain dataset, just using the context was the best model. Thank you for your attention. Our source code for reproducibility as well as the dataset are publicly available on this GitHub link. Have a nice day.